this is term 3, week 7 physics. Very easy. Question 1, the nuclear reaction where a heavy nucleus splits when you bombard it with a neutron, fission. Okay, so if they said it forms one heavy one and two of them combine to form one, then that's fusion. Don't get confused between them. Question 2, okay, which of the following are disadvantages of nuclear energy? This is old, it's repeat. In case of failure, the radiation can seep through the environment. Nuclear plants pollute the environment with greenhouse gases. No, we said nuclear energy, it doesn't have any radiation. The half-life of the nuclear waste is long. Remember, nuclear waste always have a long half-life, but some of them don't. Nuclear plants contribute significantly to global warming. No, we said it has nothing to do with any greenhouse gases or anything. A very large amount of fuel is required to run a nuclear plant. No, all you need is just uranium. Okay, so it's chill. You don't need a lot of fuel. Question 3, which of the following are advantages of nuclear energy? It does not contribute to the greenhouse effect, and it only runs on a smaller amount of fuel. Is there psychological bias? Is that advantage? No, this is wrong. Does not require protective material? Obviously, that's wrong. Question 4. Okay, this is the new topic for today. It's energy transfer and work. If I'd explain it all fast, okay. Whoa. Okay. Work is defined as the transfer of energy, or the energy transfer per distance, over a certain distance. Okay, it's measured in joules. Okay, and its work equals, any work equals the force times the distance. Okay, however, sometimes when you have an angle, it's cosine alpha. Okay, the angle might not be given directly, you might have to use some geometry, but it's very possible. Okay, work is force times distance times cosine alpha, but usually it's just force times distance. Okay, how can I use work? Let's say I have a body A, body B, and they form a system. Okay, body A gave B 20 joules. Okay, so how can I define the work? The work done by A is equal to 20 joules. Okay, so the energy lost by A would be 20 joules. However, the energy gained by A is negative 20 joules because it's losing. Okay, that means if you were to say it gained, it would gain negative, right? If you're gaining negative, that means you're losing, because they ask that sometimes. Then we'd say the work done on B would be 20 joules, right? So it gained 20, and it would be losing negative 20 joules lost, because since it's gaining, then it would be losing negative. If you lose a negative, then that just means you're gaining. This is all you need to know, and it's pretty much that's it. If it's in a closed system, if I isolate the system A and B, always know that the total energy is always constant if it's an isolated system. Let me go back to the Chrome. Oh shit. Okay, two bodies P and Q. Okay, two bodies P and Q, they form a system after some interactions. Q has lost 80 and P has gained 60. Okay, so body Q has gained negative 80. Why negative 80? Because it's losing 80. So that means it will be gaining a negative amount. Okay, the system has gained 140 joules. Obviously that's wrong. Okay, that just doesn't make sense. This is losing 80, this is gaining 60. Minus 80 plus 60 is negative 20. So the system would be losing, it lost 20 joules. That's why this one here is correct. Because if it was negative 80 then plus 80 here, then they cancel out and the system wouldn't have lost anything. So is this system isolated? Obviously not. It's not isolated. It lost some energy to the environment. Okay, the system has gained negative 20 joules, yes. It's the same as saying lost 20. You can just say gained negative 20. Question 5. Okay, two bodies P and Q form an isolated system. Which statements are true? Okay, is the energy gained by body P equal to the negative energy lost by body Q? No. Okay, to help you understand this, we're going to say P gave Q 20 joules. Okay, this is just to help you understand it. Okay, So the energy gained by body P in this case would be negative 20 joules. Okay, is that equal to the negative energy lost by body Q? Okay, since Q is gaining 20, that means if you were to say it lost, it would have lost negative, wait, if it gains 20, so it lost negative 20. If it lost, right? Because losing negative 20 would be the same as gaining 20. Okay, so P gave negative 20. Q lost negative 20. So they're saying the energy gained by body P is equal to the negative energy lost. So is negative 20 equal to negative 20? Negative 20 is positive 20. So this is wrong. Okay. Energy gained by body P gained negative 20 equals the negative energy lost by body P. Okay, so the energy gained by body P is negative 20. How much did it lose? It lost positive 20. So what is the negative energy lost? So negative positive 20, which is negative 20, which is the same as negative 20. So that's correct. Let me erase some of this. Hold up. Oh. Okay. The energy gained by body P plus the energy gained by Q equals 0. Okay, if P is giving Q 20, so P gained negative 20 and Q gained 20. Add this and this and you get 0. That's correct. Energy lost by P plus the energy lost by Q is 0. Okay, how much did P lose? If it gained negative 20, it lost positive 20, right? Because it's giving 20, so it's losing plus 20. How much did Q lose? Since it gained 20, it lost negative 20. Okay, add these, plus 20, negative 20, you get 0. Energy gained by body P equals the energy gained by body Q. Okay, obviously not, since this is giving this, so what this is gaining is obviously different from what this is gaining. I know it's a bit confusing, but it's just the wording. It would be easier if you use actual numbers. Question 6. Okay, you have to know if there's energy transferred or not. Okay, the easy way to do this is see if there's an external force acting on it or not. Okay, so let's see here, the book resting on the table. You could draw the table like this, so you'll have a book over here. The book has the weight acting on it, and it has the normal reaction. Is it moving? No. So obviously, no transfer of energy. A bucket is lifted upward, so you're applying a force to lift the bucket. So is there energy transferred? Yes. A rock travels uniformly through open space. So let's say this is the rock and it's all in space over here, yeah? It's in space, there's no forces. So is there energy transfer? No, so no transfer. A ball is in free fall. Okay, when something is free falling, okay, it's accelerating, صح? So you see how the ball here, it's falling down with the weight and it's always accelerating. Since we said free fall, that means there's no air resistance acting to resist the weight force. So will it be decreasing? No. So there's only one force acting on it, the weight. So that means there's energy. Since he said free fall, but if they just said falling, that would be different. Question 7. Okay, a person is pulling a box along a rough floor using a rope parallel to the ground. The tension in the rope is 25 and the box moves through 2 meters at a constant speed. The work done by the frictional force is negative 50. Okay, so let's say you have the box on the ground, okay? He's pulling it through a rope, this rope. Okay, he's pulling it over here, 25 newtons to the right, yeah? And it's moving through 2 meters. Okay, they want the work done by the friction. Remember that the friction is always in the opposite direction. So if we're pulling to the right, that means the friction will be in the left. So, you know that the force acted by the friction, since they said constant speed, that means the force of the friction cancels out the force of the pull. So if this is 25 here, it will be negative 25. So the work of the friction, small f, would be negative 25 times 2, which is negative 50. Because we said work of any force equals that force times the distance. Okay? And since there's no angle, you don't have to multiply by cosine alpha. Go question 8 now. A box of mass 15 kilograms is lowered through 2.5 meters. G is 10. What is the work done? Okay, I forgot to mention this in the notes. But you can say also that work also equals, the work of any force can also equal mgh. Okay? Why? Because mg is actually force. And h is the same thing as saying distance. So mgh and force times distance are the same exact thing. Over here, to find the work done by gravity, I can just use mgh, and I'll use 15 times 10 times 2.5, which is 375. Question 9. Okay, A system made of P and Q is isolated, okay? Remember they said isolated. The total energy of the system is 200. If due to an interaction, an object P has lost 20, then the energy gained by Q will be 20, since it's an isolated system. So let's say, imagine this, P, Q. They tried tricking you with putting 200, but that has nothing to do with it. P lost 20. So what's gonna happen to Q? It's just gonna gain 20. It won't gain 180 since it's an isolated system. Isolated meaning, khalas, it's only what happens between these two objects. That's it. It doesn't matter about the total energy in the system. Question 10. A block of weight 8 newtons is sliding down a ramp at 30 degrees and the box moves through 1.5 meters. Okay, the work done by the weight is how much? Okay, we said the work of any force equals force times distance times cosine alpha. Okay, if you use alpha as 30 degrees, you're gonna get it wrong. Okay, because the way they explain it in the book, I'll show you now. Okay, what they do it, how they do it, alpha is the angle, okay, is the angle between the force and the distance. So let's say I have the box like this, okay, here. If it's sliding down, that means it's like, what's the weight causing it to slide down? What's the force causing it to slide down? It's the weight, right? So, and the force is the weight. And the distance is obviously this in the ramp, right? So I want this angle over here. This is the angle I care about. But what did they give me? They gave me the angle of the inclined plane, which is 30. They gave me this 30. And how does this 30 benefit me if I want this? I'll show you. Let me go back to the question, how to solve it. Okay? You have this here. I'll make it a bit bigger. Box is over here. The weight is always acting perpendicularly downwards, W. You have 30 degrees as this incline, okay? And I want this angle over here between the force, weight, and the distance. How would I find this angle? Okay, think of it like this. This here is a right triangle. So if this is 30 degrees, over here it's gonna be 60 degrees. Okay, then now it's basic geometry. If you have any line, okay, here's 60. How would you find the other angle on the line? It's gonna be 120, because you know the angles on a line add up to 180. They're supplementary, they form a linear pair. Okay, so if this is 60 here, this here will be 120. So my angle is not 30, my angle is 120. So what do? I do the work of the force is gonna be the force, which is 8, times the distance 1.5 times cosine 120. And you're gonna get -6, okay? But the work done by the weight, okay? Why would you get -6? Because alpha is greater than 90. That's in the book. I'm not going to bore you with the explanation, but since they want the work done by the weight is pulling it to the left, right? Is the box sliding down to the left? Yes. If the force causes the object to move in the same direction as the force, then you just make it positive. No need to keep it as negative, okay? Just think of it like that. If it's going in the same direction as the force, then khalas, keep it positive. No need to keep it negative. You only put it negative when it's opposing. Since the box is moving down the ramp, the same direction as the weight is pulling it, then you just keep your answer as positive. Question 11. A car of mass 1,600 accelerates from rest under the action of a force 800 newtons. The speed of the car after moving a distance of 100 is equal to what? Okay, look. We have, it's called the work energy theorem. Delta KE equals delta W. Okay, wait, before I go back into question 10, so we drew this over here. It would also work if you used 60, because technically 60 is also between the distance and the weight. So if you use 8 times 1.5 times cosine 60, you'd get +6. This works also. If you want to do that works, I guess. But if you get a negative answer, then you probably just have to make it positive. Okay, back here, the work energy theorem is delta KE equals delta W. Okay, the work done. So the change in kinetic energy, okay, which I didn't write here, but kinetic energy is equal to, I'll write it here, kinetic energy equals to half mv squared. Okay, memorized, I guess. Kinetic energy half mv squared. For the change in kinetic energy, okay, is equal to the change in W. How do you know when to use this? You know when to use this when they give you, what is it? When they want velocity, when you have a velocity, when you have a distance, when you have a force, and when you have a mass. You have mass and velocity, you immediately know you do have mv squared, kinetic energy. If you have a force and a distance, then you know that's work. But what if I have work and kinetic energy? You use delta KE equals delta work. Okay? Delta KE basically means kinetic energy final minus kinetic energy initial equals, you could just say the work, actually no need to say delta, just keep it as work, okay? But in this case, kinetic energy is actually half mv squared. So let's say half mv squared final minus half mv squared initial equals the work of the force. Okay, what is my initial velocity? They said from rest. So if the initial velocity is 0, then that means the initial kinetic energy is 0. So I can just scrub all of this out, and I'll get that half mv squared equals the work. So let's just do this. Half times the mass, which is 1600, times the velocity squared, we don't know it, right? We're trying to find it, equals the work done. And the work done, you know, is force times distance. So 800 times 100. Whoa, what the fuck? No, what's this? How do I go back? No, okay. 800 times 100. You solve this equation, you're gonna get 800 v squared equals, I think, 8000. And you're gonna get v squared, no, 80,000. V squared equals, if you divide by 800, you're gonna get 100. You're gonna get v equal to. Okay, that's it. Question 12. Okay, you have 0.2 kg ball, 20 meters. Okay, they said g equals 10. What's the work? When they give you the mass and the height and whatever, you use the work done, you use mgh instead of force times distance. So you do 0.2 times 10 times 20. You get 40. Question 13. How many questions is this? 16. Right. Okay, two bodies P and Q form an isolated system. After an interaction with Q, the energy gained by P is plus 50. Okay, so how much is gained by Q? Okay, P, Q. Okay, if this gains plus 50, so how much is this going to gain? Obviously, since this probably gave this 50, that's how it gained. So if this gained 50, that means it lost 50 over here. So it gained negative 50 over here, right? So if Q lost 50 to P, P gained plus 50. So if this gained plus 50, that means here it lost 50. And if it lost 50, instead of saying lost 50, you can say it gained minus 50. So energy gained by Q is minus 50. How about the net change of the energy? It's always 0. Why? Because they said isolated system. It's closed system. For no external force acting. The total sum will remain 0. Always an isolated system. Okay, this is momentum. I don't know why they gave us a question for momentum. The mass of a gun 0.5 and the mass of the bullet 0.009. Okay, the bullet is fired, leaving. Okay, it leaves the gun at a speed of 300. Okay, in an isolated system, the total momentum is always equal. So before is equal to the momentum after. Remember, PB equals PA, right? The momentum before is always equal to the momentum after. So what is the momentum before? P equals mv, right? So momentum mass 1, velocity 1 equals mass 2, velocity 2. So the bullet is 0.09 times 200. So 0.009 times 200 equals 0.5 times v. If you solve this, you're gonna get v equals 5.4. Question 15. We have to know if it's non-renewable or renewable. You just get this from the book. A natural gas runs out, so it's non-renewable. Hydroelectric, it's water, and you know water is renewable. Wind is always renewable. Tidal energy is basically waves. So easy. One is. Question 16. Okay, the most important negative outcome of a nuclear station is always the waste. Okay, waste is the bad one. Okay, and what is the process utilized? We use fission. What is the source of energy? Uranium. Okay, that's it. Thank you so much for watching. Good luck. Shout out to Kinetic.